Okay, good morning, ladies and gentlemen. You are very welcome to the precise application of fertilizers webinar here this morning, which will be coming live from Kildalton Agricultural College. We will be joined by a number of key experts who will demonstrate the key steps when it comes to ensuring an accurate and precise application of fertilizer. The focus this morning will be very much on the setup of the fertilizer spreader to deliver the correct rate in the right place. With the continued increase in the cost of fertilizers, it is critically important that we use fertilizer as efficiently as possible, from good fertilizer setup to applying them under the right conditions to maximize the return from very expensive input on farm. At this point in time, we are now moving into the main fertilizer season on grassland and tillage farms, and fertilizers will be used very, very efficiently by both grassland and tillage crops as the conditions for growth are on the increase. For example, soil temperatures are increasing. We've brighter, sunnier days, which drives the energy to drive plant growth, and we've also better soil conditions. On grassland farms, fertilizer applications will be well underway as we speak, and over the coming days and weeks, fields will be closed up for grass silage crops and receiving their main dressing of fertilizer. It will be very, very important to fertilize silage crops correctly, as with the projected tightening of feed and fertilizer imports, making a large first cut of grass silage will be vital for the winter ahead and needs to be planned over the coming days and weeks. I am also joined here this morning by Tim Shields. Tim is the president of the Fertilizer Association of Ireland. Tim, you're very welcome to the webinar here this morning. There is a lot of talk about fertilizer, and it's very much the topic of conversation as over the last number of weeks and months prior to that as well. Tim, can you give us some insights as to why fertilizer prices have continued to increase over the last number of weeks?
Hi Mark, thanks for that. Yeah, just before we go into that, look, this is the first time we've done this in conjunction with Teagasc as an online event, so the Fertilizer Association are delighted to be part of this. It's a useful thing, and it's everybody gets a really huge amount of information from it. So thanks to everybody involved as well. Yeah, on your question, Mark, look, the price of fertilizer is, look, you're going back to even this time last year. Not even before I even mentioned the Russia-Ukraine conflict. The price of gas steadily increased all of last year, which had knock-on effects for production, where we had some factories close down production, limited production. Other countries then put in export bans of fertilizer, so that put a further stress on product coming to the Irish market. Shipping costs doubled as well. So all those factors were there. And it really was, it was predicted that first fertilizer supply was predicted to be very difficult this year, and then over the last month or so, the Russian conflict has further exacerbated this situation. So with all those issues, it's really put fertilizer prices, which is in most cases, which has gone by a fourfold increase, Mark. So it's difficult.
It's very much down to supply and where it's coming from, Tim.
Pure, absolutely supply and demand, yeah.
And at the moment, Tim, what do you advise farmers to do to ensure that they have sufficient fertilizer supplies for both grass and tillage crops at the moment?
Yeah, it's very simple, Mark. Look, speak to your merchant, speak to your co-op, talk to them. They're the guys who will have the fertilizer. They'll have fertilizer in the yard. Definitely, maybe your first choice may not be your option this year. Definitely have a look at your nutrient management plan. If you haven't got one up to date, get it up to date. Even if you have soil tests going back for last year, the year before, have a look, see what you need. Maybe what you did last year, you don't need to do it this year. Have a look at it and just have a double check and see what you need. And I will also stress lime as well. Get your pHs. If you have any soils that have a pH under 6, they would be a big red flag to me. I'm like, get your lime and get those soil pH up, because if you're putting out P's and K's, even as well, and your nitrogen that's onto soil that's suboptimal pH, you're definitely not using your fertilizer as efficiently as you can.
Okay, so what you're saying, okay, that's brilliant, Tim. So what you're saying to me is contact your merchant, see what you want, have a look at your fertilizer plan, where you have high P's and K's, omit P and K, and also lime. Lime is still definitely on the cards and very, very important in terms of fertilizer use efficiency.
Yeah, and just one more thing. Look, the price is huge as well. So bear in mind might have different credit terms that you have with your suppliers than you did last year. So again, just
Okay.
important thing to remember.
That's excellent, Tim. Thank you for that. Okay, I suppose just to remind everybody on the call, please submit your questions on the Q&A, and we'll try to answer them as we go through the morning, and also we'll have a Q&A at the end. So our first speaker here this morning is Liam Fitzgerald. Liam is a lecturer here at Kildalton Agricultural College, and Liam is going to bring us through the setup of the fertilizer spreader. So I'll now hand over to Liam.
Okay, thanks, Mark. So just before I start to talk about the setup of the machine, I just want to take a minute to talk about health and safety. Anytime you use or operate machinery, there's always that risk of injury or worse. So it's important to, before you complete a task, to just run through the risks that are involved with the job you're going to do. If we take in terms of applying fertilizer, the key risks that are involved with that would be crushing or striking. So if we talk about the bulk bags of fertilizer, there's always that risk of being crushed by the bag or being struck by that bag. So when you're loading the machine in particular, so in order to control that risk or minimize the risk of that happening, positioning yourself in the right spot to avoid any injury is important. So standing to the side of the machine when you are loading the fertilizer spreader and not reaching under the bag. So having something like a sharp blade on the end of a long stick is important, that you don't have to reach in under the bag. In terms of 50 kilo bags, the risk there is back injury. So proper manual handling technique is important there. Maybe if possible, have two people that'll have to load, and try and have the hopper, the spreader low, and maybe the bags of fertilizer at a level that you don't have to physically lift the bags into the hopper. You maybe just drag them across. In terms of machine setup, the starting point of having a machine that will spread fertilizer accurately and evenly is having a machine that's well maintained, in good working order, and set up properly on the back of your tractor. So in terms of good working order, what are we talking about? Well, we talked about the broadcast mechanisms initially. So if we look at this machine, it's a twin disc spreader. So we're talking about the spinning discs. Make sure that they're moving freely, that they're not seized, and that they're not excessively loose, that the bearings aren't loose in the machine. If you've got an oscillating spout machine, the principles are the same, that the spout is moving freely, but again that it's tight. Staying with the discs, you're looking at the vanes as well. Making sure that there's no excess wear on your vanes. Again, that would have an impact on how even that machine spreads. If your vanes are starting to get worn, it'll slow down the speed at which the fertilizer leaves that disc. So it will have an impact on the evenness of spread. So here we have an example of a worn disc. Hopefully the camera's picking it up, so you can see the surface of that the surface of that vane there. It's starting to get excessively worn, and there's also a hole after being worn through it, and that will impact on how even your fertilizer will be spread if you neglect to replace those vanes as needs be. Moving on from that, then the regulator setting to adjust the flow rate of the fertilizer from your machine. Again, that can be adjusted, that can be set, because you will over the course of a year, over the course of different crops, you will want to set different rates of fertilizer. So to be able to set that properly is important. And tied in with that then is the shutter doors on the bottom of your hopper, that they're opening equally on both sides of the machine if there's two shutter doors in the machine. And again, that they are open and closing freely as well. Your agitator in the bottom of your hopper, that has an important function to have a consistent flow of fertilizer from the hopper onto your disc. So again, make sure that they're moving freely and that they're functioning properly. If your machine has a boundary mechanism on it, again, that's working properly. So we have here on this machine a deflector. So you want to make sure that that's able to drop down in front of your disc and also be lifted up out of the way as well once you've completed your boundary spread. Proper maintenance of your machine is important, and that does lead to a properly functioning machine as well. So what kind of maintenance needs to be carried out in the machine? Well, regularly wash your machine. after every use if possible, because again, fertilizer is a very corrosive product, and it will cause rust and it will cause issues with the machine if you don't wash your machine properly. Grease it regularly as well. So refer back to your operator's manual as to what components need to be greased and how often they need to be greased. And even apply a coat of anti-corrosion oil to your machine on a regular basis, just to preserve that machine and prolong its life. In terms then of the proper setup of the machine on the back of the tractor. So the starting point is, once you attach your machine to the back of your tractor, it's important to be dead center on your tractor, that it's centered on the rear end of your tractor. The best guide for that is making sure your top link is straight. You can adjust and move the machine over and back behind your tractor and tie it and tighten it with your stabilizer bars. You want a maximum play or sway on your lift arms of no more than 5 centimeters. So once you have that set, then the next step is to get the machine to the working height. Setting the machine at the correct operating height has a huge impact. If you get that wrong, it's going to have an impact on your spread weight, your bout weight, and also how even your fertilizer spreads. To get the figure that your machine should be set at, again, you refer back to essentially it's the fertilizer tables will tell you. So when you're setting and calibrating your machine, you'll be able to get that figure from that. Generally, the point at which you measure from the machine varies between machines, it varies between manufacturer or types of machines. But again, if you refer back to your operator's manual, it will tell you where to measure from in the machine. But get the height of the machine set right. Once the height of the machine is set, then it's about adjusting how level your machine is. So we need essentially you need your machine level left to right. Okay, you don't want it leaning one way or another, because again, if you have it leaning one way or another, that's going to impact on how even your machine spreads. If you can imagine a machine leaning to the right, that disc is throwing fertilizer towards the ground, whereas the other disc is throwing the fertilizer higher into the air. So for that reason, you need your machine as level as possible on left and right. The majority of occasions, you will want your machine level front to back as well. So adjusting the top link on your machine to make sure that the machine is level, same height at the front as at the back. Because again, if you don't have that machine level, if the machine is pitched down towards the ground at the back, you're not going to get your width that you're looking for. If you have it pitched up at the back, the fertilizer may be traveling further than you necessarily want. There will be occasions on certain machines where you might want that higher pitch at the back if you need to get a wider spread width. But for the majority of occasions, you want your machine level front to back. So if you can have a machine that is in good working order, is well maintained, and then is set correctly on the back of your tractor in terms of getting the height of your machine right and making sure that your machine is level, it is the first step in getting an accurate spread of fertilizer. So that's really all I have to cover here.
That's super, Liam. Thank you very, very much. That's very comprehensive. You've given a great run through. I suppose just one quick question, Liam. What are the most common mistakes, or what do you find most common out there that people sort of overlook when it comes to setting up the fertilizer spreader?
The most common mistakes would probably be not having the correct height of the machine set. So getting your measuring tape out and setting the machine to the height that you need. That's probably one of the biggest mistakes out there. The other one then would be leaving the vanes wear too far, let them go too far. And because that again will have an impact on how even your machine spreads. So they'd be the main two that we'd see out there.
Okay, that's excellent, Liam. Thank you very, very much. Now, folks, just to remind you to put questions into the Q&A. We also have people tuning in from North America, so good morning. We'll now move on to our next two speakers. We have Eva Ross and John Carroll from the Fertiliser Association of Ireland, and they are going to bring us through the key characteristics of fertilizers when it comes to setting up the fertilizer spreader. So good morning, Eva and John, and over to you.
Thanks, Mark, and good morning, ladies and gentlemen. Yeah, when it comes to the quality of the fertilizer and looking at the physical characteristics, there's generally 4 areas we need to look at, and that's the bulk density of the fertilizer, the shape of the fertilizer, the size, and also the strength. And it's important to look at these characteristics because it'll have a direct impact on the evenness of the spread and also then the spreader settings that you use. So I'm going to look at the size of the fertilizer and also then the strength test, and then I'll pass over to John then to take us through the bulk density and also the shape of the fertilizer. So when we look at the size of the fertilizer, generally what we're looking for is that 80% of the granules that they fall between 2 and 4 millimeters. And the reason for that is that you'd have a nice even spread out in the field when you have the 80% between that 2 and 4 millimeters. So this is a sieve test here. So I have the fertilizer sample in the 4.5 plus mil compartment here. And then what we're looking for then is that 80% goes between 2 and 4 when I shake it through. So bit of a wardrobe malfunction here. Okay, and there we're looking for then, as I said, that 80% there between that 2 and 4 millimeters there. So you can see the majority there is between the 3 and 4. If you had quite a lot of granules here in the under 2 millimeter section, and then a number of granules here in the over the 4 millimeter section, then that would create then an uneven spread then in the field. So that's the size of the granule. When you look then at the strength of the fertilizer, then we've got this strength tester here, and what we're looking for is that we can score a 6 or over. And the reason the strength is important is that when that fertilizer hits the vein of the spreader and then travels up to sometimes 24 plus 24 meters, you need a good strong fertilizer to be able to carry through and land that 24 meters or over. So I've got the ring here, and as I said, when we're looking to test the strength of it, we're looking for a score of 6 or over. So we've got a CCF fertilizer here, and so you can see there now that's scoring 10 there, and we'll just try another 1 or 2 here as well. And again, that's the ring is going up there to 10. So that's a good strong fertilizer, and that'll carry the 24 meters or over there. I've also then just got a urea sample here as well, just to compare that CCF to. And again, that's scoring there at 10, and we'll just do another one here. And that's scoring a 7. So again, that's a good quality urea there.
They'd be 2 good samples then, Eva, in terms of a good spreader. To be little shatter on the discs with that.
They are, Mark. Yeah, like if it was scoring, say, you know, under a 5, under a 5.5 or so, yeah, the fertilizer to chatter there on the vein, and then it really just end up turning to dust in some cases. So that's why you need that good strong fertilizer to hit the vein and carry through the distance.
That's super.
So that is all from me. I'm going to hand over to John.
Questions coming in the chat there.
Mark, just while you're there, and it came to me, I had this question this morning. Can you reiterate the issue about spreading urea and slurry?
Urea and slurry, again, urea and slurry, there's no real issue, Tim, around urea and slurry. But look, ideally we should leave at least maybe, you know, 4 or 5 days between the application of urea and slurry. It's more so to do with a can-based fertilizer and slurry. So again, if you are spreading a can-based fertilizer, you should leave up to a week of a gap between slurry and a can-based fertilizer.
And is that true for protected urea as well?
Protected urea, again, the same story, Tim. There's no issue with protected urea and slurry. I say it's only if you have a can-based fertilizer, that's when you need to leave a gap.
And what, you know, when there's probably a lot more organic manures and slurry going out on site ground this year, Mark. How, like, say if a guy using 3,000 gallons of slurry, what can he leave out? compound wise, or what should you, or how can you match it? Say if it's index 3 or if everything is equal.
If you had index 3 ground for P and K is very fertile. 3,000 gallons of cattle slurry, good quality cattle slurry, will deliver the majority of P and K, Tim, and about 25% of the crop's nitrogen requirement. So you're looking at then balancing it up with a straight nitrogen plus sulfur. A Sulcan or a protected urea plus sulfur.
And potash is very important size, isn't it, Mark? That you want to.
Potash again, Tim, is very, very important. Again, where you're not spreading any slurry, again, you're looking at a blend, something like a 13-6-20, say 3.5 bags to the acre, or maybe something which is quite popular out there is a 10-5-25, again, 3 bags to the acre.
You're nearly matching your nitrogen rate to your potash rate. You're nearly 1-to-1, aren't you?
Exactly, Tim. Yeah, it's like we're talking with the increase in the price of nitrogen, we're talking about applying 100 kilograms of nitrogen per hectare, and again you'll be applying about 90 kilograms of potassium. So again, you'll be matching both the nitrogen and the potassium, Tim, for that silage crop.
Can you hear me now, Mark?
That's good, Francis. Yeah, that's excellent. Okay. Sorry for the.
Okay, sorry about this. No, sorry, folks, about that. No, it's typical. No matter how many times you test these things, they always play up. Okay, so I'm just going to talk a little bit about, I suppose, setting the machine up. Now, in fairness, the lads have mentioned the fact of, I suppose, the basic settings, but also, we spoke about the different types of fertilizers. And I suppose the challenges that we have there is that there is so many variations in fertilizer, in bulk density as well as the actual granule size. Getting the actual spread pattern right can be a challenge. And like, remember, we're relying on, these discs, and essentially, just that vein, so 6 inches or 200 mil of steel to actually broadcast that fertilizer, anything up to maybe 30 meters in some cases. So making sure that obviously that we mentioned that Liam said about the vein itself being in good quality, but making sure that the actual vein itself is set up in the right angle. And I suppose the more we change that angle, the more of an effect it's going to have, would say. So your machine has adjustments on it, so you can actually adjust the angle of that vein along here, and there's numbers along this area here as there is along this area here. So again, getting those settings right is very important. And I suppose if you can imagine, if we just take the vein here, essentially what you're doing is you're actually changing that angle, so if we're looking at that horizontally now, if the fertilizer lands on this here, it's going to move off it reasonably quickly. If I change that even further, it's going to move off much quicker. Or the steeper I come up, the longer that fertilizer is going to spend on the vein. The longer it spends on the vein, the more energy it's going to get, and the greater distance it's going to travel. So getting that angle right is important. Now there is books and that came with the fertilizer spreader, so you will have gotten information booklets such as this with the fertilizer. But I suppose, look, the reality is, these books are actually, they're quite complicated, and a lot of people tend to shy away from them. So thankfully, look, most of the manufacturers have actually introduced phone apps which allow you to get the settings for the machine. So I'm just going to take out my phone here, and I'm going to demonstrate one of those apps here. So Liam, if you might stop sharing there, please, if you don't mind. Hopefully you can see that screen. Can you see that screen there, folks?
We can do, Francis. Yeah, looks good.
Yeah, okay. So look, most of the manufacturers have apps, and I just have a selection of some of them here. So there's some of the Amazon apps there. I've some here from Roush, from Bogbel, some from Kverneland, and Vicon. Just while as we're here in front of the Roush machine, I'm just going to take a look at this. So I suppose the first thing that you'd actually do is you'd go in here and create a profile for your machine. So you'll actually set up this profile once, maybe two, but again, you'll just basically have to pick your spreader. So you'll go down through the list, find the spreader that you have. So an MDS 11.1. The disc type is asking you, so what disc is on the machine. the working width then that you normally use. So again, this might be one of the reasons that you might set up 2 profiles. We'll just say 15 meters. And then when you have electronic control in the unit, and up in the top corner, then you can just hit OK. And if I hit OK, it'll probably tell me how this created. No, I don't. So from there, then you have your profiles there. The next thing you're going to is the second tab along the bottom, and we're going to the fertilizer chart. So in here, those 4 or 5 profiles that I've created are saved. So in your case, you'd probably actually only have maybe 1 or at most maybe 2 profiles here along the top, but you can flick through those quite easily. So if you had maybe one for 15 meters and another one maybe for a wider or narrower working with, so we'll stick with the 15 meters. You can see further down then there's a range of different options there. So we've seed, slug killers, fertilizer, and the fertilizer indent guide. So typically we're going to go to the fertilizer. In here, then you're going to find the type of fertilizer. So we mentioned earlier on, we were talking about the different ureas or the NPKs. So I'm just going to pick an NPK, normal dressing or late top dressing. So again, just depending on the type of application that you're going, it will have an effect. Again, the crop height, as Liam mentioned, the height of the machine over the crop, will have a big bearing. But we'll just say we're going doing normal dressing. And if we just scroll down along there, and we'll just pick maybe just an 18612 there. From there, you can see one of the first things we're getting is this halfway down the page, there's normal spreading, and it says D4 and C1. The D4 and C1, they're actually my vane settings, and I'll show you those in a second. The second item there is the PTO speed. So again, the PTO speed is very important. So look, in most cases, it'll be 540, okay? But there will be situations, particularly for the wider working widths, or if you're using urea product, that you might find that PTO speed is up at 600. The next item that's there is the 6060. That's the actual working height of the machine, and I'll show you where we actually measure that. It gives us 2 measurements in this case, which is real. Now further down, then we have. Here we can adjust our forward speed. So let's say we were going to be traveling at 10 kilometers per hour. We'll set our forward speed, and then we'll set our application rate. So let's say we're putting out 125 kgs there. The meter and scale, it's telling me, should be set to 70, okay? And it's giving me a quantity of kgs per minute of 31 kgs per minute. Now, while I have the app open, I'm just going to show you this calibration test calculator. So you can see the red button at the bottom. So let's say we'll just demonstrate how we'll do this in a second. But when we're actually doing our calibration test, if we got maybe 15 kgs from, we'll say, one side of the machine, which should be 30 in total, it's telling me that my meter scale should actually be adjusted to 72. Okay. So rather than the 70 here, we'll get a little bit less, so we can change that. Now, once you have done that, you can actually, here on the bottom, you can see in the middle, there's a star. So for favorites, I can actually create that as a favorite by tapping the star up on top, and then that will be saved to my favorites list in the app. So then the next time I come back, I just have to open up that to get my list of my favorites, we'll say. So so you don't have to go searching for that every time. I just need to stop sharing here now again. I think I'm stopped again. You might share again there, Liam, will you? Am I back on the big screen again, folks?
Yeah, you're back on. Yeah, good, Francis.
Okay. Yeah. So what's the information I'm after getting there? I suppose first of all, it's the adjustments for my vanes. Okay, so I'll just show you what those letters mean. Here on the side of the machine, we have a tool which we can use to open the nut here on the back of it, and we can use that. Then we can remove the disc. So again, this will normally be a task that you can do without tools, because it's something that we do need to do quite regularly. So coming in here, I have letters here and numbers here. So it was giving us settings earlier on. Now in this case, this vein here is set to B2, okay, and the vein on this side is set to D3, okay. So we can adjust that then by putting this tool in here, pull down the spring, and we can adjust our vein over and back, okay. The other item that we mentioned was our operating height. So again, it gave us an operating height. In this case, it was saying 60. So again, we're measuring from a tab here on the back of the machine is my front measurement, or sorry, my rear measurement, and my front measurement then is actually taken from this tab in here, okay? But as we mentioned there, this was 60-60. But you will find in top dressing that tab or that measurement will actually change and will actually lift the back of the machine that bit higher, okay? The other thing that we do need to do is to measure the flow rate, okay? So again, the only way to do this on our basic machines is actually to take a bucket, okay? There is a unit here on the front of the machine, so mounted on the front of the machine. This little plastic funnel sits in here, okay? We put our bucket here underneath the machine, and then we'll actually run the machine for 30 seconds. We'll collect what fertilizer comes out, collects in the bucket, then we'll get a scales once we've collected that, and we'll just measure the quantity that's in that bucket, okay, and we'll see how that compares to what we should have. Now, as I said on the app for this machine, if that's a little bit higher or a little bit lower, we just put in the figure we have actually gotten in the bucket, and it'll actually give us a new meter setting for the front of the machine to compensate, okay. So that's the basic settings there. The other thing that I just do want to mention, and maybe Liam, you might just pan around there for a second. No matter what we do with these, set up on the machine, the only way that we can actually know if the machine is spreading correctly is actually to set out and do a tray test. So I have a number of trays laid out here on the ground. So these trays basically a half meter by a half meter. It's got a set of, I suppose, blades inside it. They're basically just compartments to stop the fertilizer bouncing back out of it. So you'd lay those out evenly across across the width of the machine and collect how much fertilizer is in it. You do 3 passes, and then once you've done that, then you just put those into a set of test tubes to see that we're getting an even distribution across the working width. But it is important, no matter what type of machine that you have, that you are doing some sort of a tray test to see that the fertilizer is actually getting spread through the full working width. Now, I do have another set of mats here that I'm just going to quickly just show you, okay? So here behind the Amazon spreader, there's another set of mats. These are easy check mats. So basically, if you can, I'll just hold one up there for you for a second. But basically, it's just a rubber mat, okay, with a whole lot of dimples here on the front of it, okay. There's 4 squares you'll see here in the corner. You basically lay out those, again, line behind the machine, and 2-3 more lines evenly distributed across the back of the machine. In this case now, I'm just going to show you, again, I'll just go to the app, so I'm going to get Liam just maybe to stop sharing again there for a second, and I'll just share the screen here again, start broadcast, and that should start now in a second. Okay.
Yeah, that's good. Yeah.
I'm just going to go to here on this screen, the Amazon. We'll just go to the easy check. Okay. In this case now, I just have a setting put in for my fertilizer spreader. Okay, we're working to 18 meters. I have 18 to 24 discs or veins. And now what I want to do, I'm just going to put in, we call this a test fertilizer, and we'll just call it, so I'm going to just continue now to my easy check. Okay, you can see here now, it shows me where I should lay out those trays. Okay, so you can see there's 4 directly behind the machine. There's 4 out 3 meters, 4 out 6 meters, and 4 out 9 meters. If I hit plus there on one of those, hopefully you can see the camera now. I just zoom down, you can see the 4 squares. I'm going to line up the 4 squares with the 4 corners, and I'm just going to take a picture there. It's reading the fertilizer on that mat. You can see the white dots are showing where the fertilizer is on that mat. Okay, if we continue on to the next one.
So that's giving you your spread pattern, Francis, is it?
It is. So you can see there, look, we 14.6 in the first, 6.7 in the next. Now those figures, as they don't actually mean anything as such, but they should be even, so they should be equal numbers. But basically, if I continue through all of those, what this app will actually do is it'll actually give me a new vein setting for the machine. So let's say, Joe, I wasn't spreading, it was spreading a little bit light out to the, at the 9 meters. It'll probably increase the angle of the vein slightly to give the fertilizer that extra bit of energy to reach that further distance out. So we can just we'll just continue on with those. So
Okay.
look, I'm going to.
That's very good, Francis. Just a quick question, Francis. Do all fertilizer spreader manufacturers have a phone app available for setup?
Look, most of the bigger manufacturers certainly do now at this stage. Either a phone app or a web-based app. So now look, not all of them do. And look, we've actually created, for that flow test, we've actually created a calculator on the Teagasc website, and we might share that later on as well, so that you can actually calculate how much should be coming out of the machine for your application rate. So you can actually do that exercise. At the very least.
Okay, Francis, I wonder, do we have time to go back to John Carroll just to get his piece on fertilizer quality?
John, you might come over to do that whole piece.
That little piece on or do we have time, or what do you think?
We can, yeah. Do you want to do that now? Yeah, we will. Yeah.
Okay, there's a question there on chat as well around nitrogen for first cut silage. Again, in the current year, with the increase in the fertilizer price, we're talking about 100 kilograms of nitrogen for first cut silage. And I suppose just interesting to note that the first 80 kilos of nitrogen delivers 75% of the yield. The next 20 kilos deliver 20% of the yield, and the last 20 kilos then generally is not paying due to the increased cost in the price of nitrogen. Okay, John, back to yourself there.
Thank you very much, Mark, for my second run. I hope you can hear me this time.
Loud and clear, John. Excellent.
Okay. Well, I need to talk about bulk density first of all, of bulk density of fertilizers. And basically, I have a liter container here, 3 of them. So we have filled the 2 of them. I've just used the first one to tear the weigh scales. And I want to show you, most fertilizers nowadays, most modern fertilizers are manufactured to about a kg per liter. And that means it makes the spreading that little bit easier and more uniform as you go from product to product. So this one here is reading 1.01 kilograms per liter. Now, and as I say, the one big difference is urea, and you all know that because most urea bags hold 0.375 of a ton. So basically, we have 0.74 on urea here. So about 3/4 of the weight of an ordinary fertilizer. That has very big implications. Number one, for capacity when you're spreading, your spreader will hold less, but also in the spreadability. And we talk about it in terms of the 2 balls. So golf ball being much heavier and the table tennis ball. So basically, if I throw those, the table tennis ball will go a lot less distance, and it will also be much more affected by wind also. So therefore, when spreading urea, one must be much more careful with the spreader settings, and number 2, with the weather as you spread on that day. So that's basically urea and urea-based fertilizers, lighter fertilizers. So it's always good to check the density of fertilizers. But as I say, most companies nowadays manufacture to try and get something about the kg per liter. I also want to talk about products then. So we also have uniform CCF products, whereby you have the NPK in the 1 granule, and that's much easier to spread uniformly. A lot of blends, in fact, NPKs, etc., many of them come in blends, whereby you have 3 different raw materials making up the blend, sometimes up to 4, and therefore they need to be manufactured well so that the different products go to different distances in that in that spread. So that we get that uniformity of spread. In other words, that we don't get the potash going a different distance than we do the nitrogens in the mix. But today, most manufacturers blend to make that easier. But it's very important, as Francis says, to go to the manufacturer's recommendations for spreading settings on your different spreaders. I also want to talk very briefly then about most fertilizers nowadays are round in shape. But however, potash can be angular, and therefore, and some other products from time to time can be angular. So we just need to be that little bit more careful with the spreadability of round versus angular, because they do come off the spreaders at different types. So the round will roll off the vein of the spreader, whereas the angular is more thrown. So they can have slightly different spreading characteristics. So I think at that mark I have most covered.
Okay, that's super, John. And John, for a blend, is the density, are we around 1 kilo for a blend?
Yeah, so all blends except urea-based blends will be somewhere around that kg per litre also. So yeah, and as I say, the importance this year with the amount of urea and urea blends that will need to be there to fulfill the market, we will see urea being used for silage ground, sometimes top dressing. The importance to get that urea spread evenly so that we don't have striping and wastage of fertilizer. That's very, very important. And I suppose the one take-home message today, whether it's urea, protected urea, whatever, to make sure that you know the settings on the machine. They'll be different than conventional spreading, and to get those right, and to check your spreader before you go out and spread.
Okay, that's super, John. Okay, we'll move on to Dermot Forrestal. Dermot is going to speak to us about new technologies, or technologies that are now available on both spreaders and tractors to improve in-field accuracy or precision, especially on the headlands. So Dermot, you're welcome. I'll now hand over to you, Dermot.
Okay, can you hear me there, Mark?
Yes, that's good, Dermot. Perfect.
Okay, yeah, look, I won't keep you too long because the time is running on, but just to talk a little bit about technology, as they say, Mark. And I suppose the main thing to say is that, you know, when people think of technology, they're often thinking of electronics, GPS systems and things like that. The most important technology on any fertilizer spreader is the actual spreading elements itself. So it is the area of the discs themselves, the veins, and the drop point onto those discs. That's really what makes a good spreader, if you like. In other words, how well it can do that to get the fertilizer applied evenly. So always keep that in mind. You know, electronics and control systems can certainly help the operation and make the task much easier. But the basic design that you want in a spreader is good design around the spreading elements, the discs, the veins, and indeed the drop point on it, and good resources then to kind of that has been gone through by Francis already in terms of setting that. So that's the key technology that's there. But while we're here, we'll move on then to talk about some other technologies, I suppose. And one that you can't see probably from the front of this, but this actual spreader here has a weighing system on it. Okay, so what this does is it's actually continuously weighing what's in the hopper of the fertilizer spreader. And that really gives us two, I suppose, advantages. One is that the calibration procedure that you need to do to get the correct flow rate, to get the right application rate, that can be done automatically. Okay, so by actually having constant weighing of the system, it allows you to do that. It's self-calibrating in that kind of context. The other thing is that a weighing system, and indeed there's other ways of measuring the amount of flow of fertilizer other than weighing. Some of them actually measure the torque on the disc, how much pressure is being put on the disc by the fertilizer falling on it. But those, by weighing or torque measurement, can also compensate for variations either in fertilizer flow as it's going through the hopper, or indeed in forward speed. So in that context, certainly a weighing system or a flow weight measuring system can be beneficial from that aspect as well. While we're at the back of the spreader here too, though, I think it's good to talk about headland spreading, because we've heard a little bit about that from the other speakers there earlier. But we did a bit of research in Oak Park there about 3 years ago. Mark Ward was doing a PhD with us, where we looked at the whole research was looking really at what happens on field headlands. But we looked in particular on about 20 farms at the spreading on field headlands. And there's a huge variation in the quality of fertilizer spreading on field headlands. In other words, it tended to be quite uneven. We divided the headland into different zones depending on how near you were to the ditch and the tram line and so on. And the spreading on headlands is quite uneven. And some of that is down to the setting of the machine, some of it is down to the design of the machine. Because when you think about it, a fertilizer spreader, all of these spreaders are broadcast spreaders. Their whole aim when they're out in the field, a good spreader will spread really, really wide and overlap the pattern. So it has a kind of a taper pattern, decreasing as you go further away from the tractor. That's compensated with the next run of the spreader by matching up with that, if you like, and that gives an overall even spread. But when we're spreading on the headland, we're doing the opposite. We're trying to get it to spread a full rate out to one side and then suddenly to stop. So it's a big ask. So the various manufacturers have different ways of doing this. Some you'll have different discs put on the spreader for a headland run. Some you'll have different vanes. In other spreaders, you actually change the direction of rotation of the discs because it then spreads off the back of the vane, which is a different shape. Some you might actually tilt the spreader to one side. Others will use a trimmer or deflector like this. So, and some may slow down the disc speed on one side. Okay, so there's all sorts of different combinations. And what's really, really important is that those are set correctly for the spreader. And I think when you're purchasing a spreader, I think you would want to give a good bit of thought as to the headland management system that's on that. Because remember too that even in something like a 6 hectare or 15 acre field with a 24-meter wide spreader, something between 20 and 30% of the area of that field is going to be on the headland. So if we're not getting that right, it's going to be a big loss. So that's hugely important. Another aspect of that headland spreading though is getting the right position for turning on the spreader when you're leaving the headland, and indeed turning it off coming off, getting that correct. And that's where GPS comes to help us. So if we move around a bit, Francis, if you can follow me, if you want to take a quick squint in the cab, you kind of see, I suppose, that all modern equipment it tends to have, control units like Francis is up there. Typically you'll have a GPS screen there, but also in this case, you'll have another screen, which is the controller of the spreader itself in that case. So that's what you tend to see on those. So to talk, because this is the area that people, I suppose, focus on a lot in terms of technology and in terms of spreaders. What does GPS bring us on a spreader? Well, that first thing it brings us is what I was talking about there on the headland. It can switch on and off the fertilizer spreader automatically as it reaches the headland. And you'd say, big deal, what does that mean to us? It can mean a lot, because with modern spreaders, sometimes if they're very wide spreading, you might have to be 20 meters into the crop when you're leaving the headland to be in the correct position to turn on the spreader again. If you turn it on early, you're wasting fertilizer. You're probably even risking lodging your crop. So by the GPS, what the GPS unit can do is it can automate that process. It knows exactly where the tractor is at any one time. And when it reaches that correct point, it switches back on the spreader. So that certainly can be of quite benefit. If you haven't got that though, you can still achieve the same yourself. There's no, there's no substitute for getting off the tractor actually and measuring that distance. Maybe use a white fencing post stake to actually mark that position and get yourself calibrated for judging that point. But certainly the GPS control will do that consistently and very accurately for you. The other thing that the GPS units can do is they can give you a degree, when you're coming on to tapered runs or short runs, they can give you a degree of so-called section control. Now, section control is probably a misnomer because that's really what happens on a sprayer where it's very precise. You turn on and off different sections on a sprayer. On a fertilizer spreader, what it does is it adjusts the rate coming out, the flow rate coming out of the spreader, so it's compensating for the narrower run, if you like, as you're meeting a tapered headland. But it also, on some spreaders, can adjust the spread pattern of the spreader, so it can bring the spread pattern in a bit. It usually does that by changing the drop point of fertilizer onto the disc by achieving that. But remember, sometimes this isn't as precise as it appears on the screen, but it's with certain spreaders, it can certainly keep the rate right, and it can do a certain amount of adjustment of the pattern to do that. So that's the use of GPS units. Is there any other technology? Well, I suppose if we move on a little bit more, on the front of this tractor here, we have, this is the Yara N sensor. What we're trying to do here is try and see, well, can we better match the demands of the crop from what we see in the crop? So the technology here is, if you like, crop reflectance technology. So what we're doing is we're looking at the crop with a camera. In this case, it's tractor mounted. It can be on a drone. You can do it beforehand. You can even do it from a satellite, but the resolution won't be as good on a satellite. What that reflectance image, what that camera image gives you is, it gives you, I suppose, a level of what we see as greenness, but it does it a little bit beyond the visible spectrum. So it's taken particular wavelengths in the spectrum that we can see. We can see the greenness, but it goes a little bit beyond that. It takes specific wavelengths, and from that, it can estimate the amount of nitrogen that's actually in the crop. It can also estimate the fullness of crop that's there as well, or the amount of green mass or biomass that's there as well. So by that, then it can adjust on the go. In this case, if it's fitted to the tractor, it can adjust the application rate of fertilizer based on what it already sees in the crop. But it sounds great, but it's often not as simple as that, because while that can give you an accurate estimate of the variability in the crop, it's not telling you what's going to come from the soil at any particular time. And it's not going to tell you what the demands from the crop are at any particular time. And for that particular reason, we have to use these systems quite cautiously. We still control the overall amount generally from other information that we have. But where some growers are using this is where they're using organic manures, and they might be going out a little bit more unevenly, rates through a muck spreader or something like that. And certainly in that case, systems like this can be used to try and improve the accuracy of fertilizer application or nitrogen application in particular in that case.
So that could be the final application, Dermot. Could it where you're trying to balance up, or you're using organic manures that maybe you're trying to, balance up the crop, the N sensor could be useful.
Exactly, Mark. It can be used in those situations, and as I said, to try and balance things within a field in particular, because in most use you will set with the limits yourself as to how much you actually apply. In theory, it would be nice to be able to give it complete control, but in practice, as I say, it's difficult to know what's going to come from the soil and what the particular demand of the crop is going to be between that point and harvest. And you can set different parameters. You can set it for, if you want to deliberately raise the protein of wheat, say in other climates where you're looking for hard wheat, you can use it in that scenario as well. But there are a lot of other parts, but it is an element that might give us more precision in the future. But there are a lot of other elements that need to be added to that before we have a completely controlled system in that sense.
Okay, very good.
Mark, I think we've moved on a bit on time. So
okay, that's 100%. There's if you want to make your way back, Dermot, for the Q&A, we have a number of questions in there. We have a number of questions on the quality of fertilizers. I suppose maybe a question for you, Dermot. Maybe we have people lined up there now. So, okay, let's kick off with some of the questions, folks. There's a question there just around maybe for John or Eva there. It's to do with fertilizer soil seconds. Would this product be up to spec regarding the strength test? Also, I presume the spreading width would have to be much closer because of the smaller granule size and the higher quantity of dust and fines. Maybe John or Eva, do you want to comment on that question?
I'll take it. Yeah, I'll take that question. So basically, with seconds, can you hear me?
Yeah, that's good, John. Yeah.
Yeah. Okay. With seconds, any fertilizer that's off spec, quality can be very, very suspect. Some a lot better than others. For me, the biggest point here is how soft is the product? Where was it? How long was it sitting around? So therefore, how soft is it gone? And therefore, it can be a lot more dusty and a lot harder to spread. So from that point of view, you'd want to certainly spread it at a lot. Certainly want to be in at 12 meters or less.
Okay, so you're sort of in unknown ground. Yeah, so again, it can be difficult to spread. So again, setting up the spreader would be quite important. Maybe a question for Liam here. Liam, in terms of setting the height, where do you measure from? What part of the machine and whereabouts do you measure from?
It depends on the machine a lot of the time. So the route that Francis was demonstrating on there, it's from the bottom of the frame. Other machines might be from the disc, other machines might be from the actual linkage pin. So it depends on the machine itself. So that's why it's important to read your operator's manual to know that.
So you're measuring from the top of the crop, or Liam, is it?
Yeah, and then it's down to the top of the crop, because obviously If you go into bare, freshly grazed out pasture, it's not a big issue. But if you go into top dress a crop that might be a higher standard crop, it's important to get that distance from the spreader right. Because again, you don't want the fertilizer to hit the ground too soon, because again, you won't get that distance, and it will affect your the evenness of spread.
Okay, very good, very good. A question for Dermot there. Do we now need GPS control to be able to spread fertilizer accurately, Dermot?
No, I don't think so. I think you can still spread accurately without GPS control. What GPS control does is gives a very convenient way of doing that. As I said earlier, I think the biggest error that can be made, maybe that GPS can help you on, is the turn on point from some of the widespread spreaders. The actual point where you turn it on when you're leaving the headland. So the GPS control will actually do that. I'd also say though that you need to have these very well set up, and they're often not that easy to set up. So the rate of speed at which you're traveling, the distance between your GPS antennae and the fertilizer, the active fertilizer spreader and all of those need to be very carefully set up. So it's no guarantee of that, if you like, but a good working GPS system can make it easier to achieve.
Okay, very good.
You can still achieve a lot of it manually.
Okay, maybe Dermot, when I have you there, maybe one more around urea. Can urea be spread better by spreaders with new technology?
I wouldn't say necessarily so. I think the thing about urea is that you need to have a spreader that's capable of doing it. In other words, that the spread mechanism, the discs, the veins, and so on, that you're actually capable of achieving the bout width that you want to achieve with the urea. And probably most importantly, that it's backed up with very good testing resources so that you can match the product, the particular urea product that you have, because urea products vary quite a bit in size distribution. So density, as John said earlier, is a negative all the time. But what you need then is resources from the spreader manufacturers so that you can match up your product to that. And it will tell you what your limits are in terms of bout width, and also what the exact settings for the machine are to achieve that bout width. So it's not a case of new technology solving anything with urea. I think it's the basic technology that's there in terms of the good spread element design and the resources backing that up, and to use those resources.
Okay.
Make a comment on that as well. You know, if you just even put in urea into the row shaft there, you know, at 15 meters, it's looking for 600 RPM on the PTO. You know, so it's looking for an increased PTO even at only 15 meters, which wouldn't be overly wide, like, you know. So with the veins, or with the veins that are on that machine. So
okay, that's excellent, Francis. There's another question here, Francis. Do you need to take off the disc off all fertilizer spreaders to calibrate the flow? Mine can't be removed without taking off the hopper. So do you need to take off the disc?
It does vary again. Look, and I suppose that's one of the challenges we have with any of these demonstrations, that, you know, from machine to machine, the actual calibration exercise or the way we do that may vary. But most machines, you know, certainly all the modern machines will have a way of actually catching that fertilizer. So you actually have to measure the fertilizers that's coming out of the machine. So some machines, I know the likes of the bog bell, it is hard to take off the disc, but what they actually have is they have an opening in the actual disc itself, and there's a pin underneath actually, so basically it turns off that disc. You pull out the pin and you open that opening in the disc, and the fertilizer can flow down through it.
Okay.
On the Vicon spreader, it's slightly different. There's actually a mounting kit that you actually buy that actually goes on around the whole disc. So basically you run it with that kit on it. It's got a funnel coming out of it, so you're actually catching every bit of fertilizer. It's kind of, I suppose, like wrapping the whole disc and vein, you know, rather than actually taking it off.
Okay, and maybe one more, Francis, when I have you there. Is it necessary to adjust the vein position for different fertilizer types if you're using the same working width?
Yes, that's an extremely important thing. Particularly, like, you know, as we mentioned, you know, particularly if you're moving to your urea products, you know, that's that much lighter. You know, it's going to need an awful lot more energy to travel out the distance. So, you know, you will find that the actual vein setting for that will actually be quite a bit stronger. So the fertilizer will spend longer on the vein to gain that extra bit of energy. And plus, we say the PTO speed might actually need to be increased as well, for that lighter product in order to give it enough energy to travel out the distance. So yes, I would highly recommend anybody going to urea that they definitely look up the settings for the machine, download the app and get the settings from it.
Okay, there's another question on the chat there. Maybe Francis, you might answer this one as well when I have you there. What do you do if the quality of the fertilizer is poor in terms of strength? So how can you adopt the spreading machine setting accordingly?
Yeah, look, as John has already mentioned there, that is definitely a challenge, with any of these fertilizer spreaders. Like you can imagine that fertilizer is dropping down onto a vein that's spinning at high speed. So if that product is soft, or certainly getting if it's below the 5, that strength test that we were doing earlier on, what you will find is that it might start to shatter, and you'll find an awful lot of dust on the back of the machine. It's going to be hard to spread that to wide working widths. You're going to have to reduce down the working width if you want to try and use that type of product, and work to a narrower working width. I think is the only way that you could actually try and achieve an even spread pattern with that. But again, you're going to be relying on the information that you're getting from the apps is going to be of little use probably, because that if you use this, they're going to assume that it is of a reasonable quality.
Okay. I have one more question here, and I'm going to maybe put to Dermot. Dermot, again, this is back to, I suppose, using fertilizer as efficiently as possible in the field. How do you manage to spread headlands evenly without GPS and additional controls?
Yeah, well, there's two parts to it. All the GPS does for you really on the headland is gets the on and off points correct. But those on and off points can be measured. And as I said earlier, you can actually get yourself calibrated by, if for instance, the correct on point is 15 meters away from the headland tram line into the field, well, actually go out there and mark that in the field and get your eye trained to what that 15 meters looks for. Okay, so that's the on and off points, right? The other part though of the headland spreading is just to do with whatever every spreader has some form of headland spreading mechanism really at this stage. In other words, it's something that alters the pattern on the headland side to make sure that it stays fairly high out to a point and then fairly rapidly drops off. None of them are perfect, but it is very important to actually set that. And your GPS systems and that don't necessarily help you an awful lot on that end of it. But it is important that you look up what is on your spreader to help you change that and to get that setting correctly, whether that's a different vein position, different veins or different discs, the disc speed itself, the angle of the spreader, even the drop point on the spreader can bring into play another vein on a different manufacturer's machine. You need to look up what it is on your machine you need to change. I would also say that, Francis showed you about trays. I think it is one place that is really useful to use trays is on the headland. In other words, even 4 trays would help you, but just to try and get the shape correct, the shape of the spread pattern correct on the headland one, very, very important.
Okay, that's super, Dermot. Thanks for that. I think we'll call a halt there. There is more questions there, but in the essence of time, again, I would very much like to thank Francis Quigley for organising this event here today with Liam Fitzgerald. I'd also like to thank Dermot Forrestal for his help and contribution as well. And I'd also like to thank Eva Ross and John Carroll with regards to fertiliser quality from the Fertiliser Association of Ireland, and also Tim Shields. This recording will be available on the Teagasc website. Also, we have a final slide there. Maybe Yvonne, you'd share the final slide there. There is a lot of information out there around managing fertilizers as efficiently as possible. Teagasc launched the soils, nutrients, and fertilizer fact sheets there. There's 20 fact sheets there, everywhere from soil sampling to fertilizer advice for silage and for grazing, to help with the use of fertilizers as efficiently as possible in the current year. Francis Quigley also has a fertilizer spreader calibration tool there that's also available on the Teagasc website, on the Soil and Soil Fertility website under fertilizer spreaders. And there's also 4 charts and 4 videos there as well. From calibration to evenness to fertilizer quality to fertilizer technologies. Also, the Fertiliser Association of Ireland has a technical bulletin that it produced a number of years ago, all available on their website there under technical bulletins. It's the precise application of fertilizer. So with that, folks, I would like to also thank Yvonne Marr for helping out here this morning with proceedings, and everybody on the call, and you, the audience, for tuning in. So I wish you all the best in 2022, and we will call the webinar to a close. Okay, thank you. Goodbye.